Not really.
Okay.
There.
Okay, so we're here today for our cup of tea meeting or presentation. We're here to just sort of hang out and have a conversation together. I'll be your host today. My name is Ivana Ristevsky, and I'll be sharing some information with you. First, some announcements. I'll tell you a little bit about the cup of tea, anybody who might not be familiar with it. A little bit of housekeeping, just so we know how to use, how to interact and raise questions. And then we'll go ahead with our article summary and then have a conversation with the group. So announcement here is we had launched our retinoblastoma research and new booklet last year. So I just wanted to let everyone know, in case anyone hasn't heard about it yet, you could find a copy at your next appointment at a retinoblastoma center or through our website. You could also email us if you want a hard copy to look through. It's a really great information about being engaged in research, and an event like today is a great example of how people can participate and share information and sort of be involved in the Canadian retinoblastoma research community. But to make sure that you're always in the loop of what's happening and are invited to events and all these great things that we host, I would like to let you guys know that we have our sign up to join our retinoblastoma research community. If you have a booklet, you could get the information from the back. You can use the QR code or on our website, rbcanadaresearch.com. So anybody who's here today and has not signed up, please do. This is open to anyone who is connected to retinoblastoma. So whether you're a family member, a survivor, or are working on research, or a clinician connected with patients who have retinoblastoma. So we'd like to keep everybody in the loop of everything that's going on. And if I can ask Roxanne, she's online here, if you could please share the link in the chat so somebody could just click and they could sign up. If you're not sure if you already signed up, you could send us an email and I can double check that for you. Our email is retinoblastoma.research@sickkids.ca. So the cup of tea, I think most people I see on the call here today have participated before, but if anyone's new, I wanted to share the cup of tea is like a journal club, if you're maybe more familiar with that term. This is an event intended to bring our Canadian retinoblastoma community together for an informal discussion about a research article. Discussions center around articles which our CRAB members have created plain language summaries for. These plain language summaries are all on our website. And our past cup of tea recordings are available on our YouTube channel, which is called Retinoblastoma Research. And building on the previous success of our cup of tea, not only are we continuing to record and host them quarterly, we're also going to be creating a podcast of the audio recording, which was suggested at our RB Research Symposium this January. So we're expanding this great event. So give you a little bit of information how we come to this cup of tea today. This is a process that we have created, and where a patient partner, somebody with lived experience with retinoblastoma, selects an article or a topic that they're interested in, and we partner them with a researcher or a clinician who may be an author of the article, and they work together to create a plain language summary that can then be shared to our community. So the Canadian Retinoblastoma Research Advisory Board helps manage that relationship, as well as provides opportunities for the meetings to happen between them, and guidance on how plain language summaries can be written for our purposes here, as well as then offering both of the partners to present their summary at this cup of tea presentation. Okay, so the article that we'll be discussing today is early monocular enucleation selectively disrupts neural development of face perception in the occipital face area. The plain language summary, as I mentioned, is available on our website. The authors of the article are Krista Kelly, Brenda Galley, and Jennifer Steeves. So just to make sure that you guys have a good, enjoyable experience, if you change your view to speaker view, then you'll be able to see the presenter and the slideshow. We can use the raise hand function or chat to share your questions and comments. You can add comments throughout. There'll be some specific times throughout the presentation where there'll be questions asked and we can have conversations, as well as at the end. And you could offer to voice the question by using the raise hand function, which could be either seen through the participant button or the reaction button. Okay, so today we have our presenters, Mitch Hendry. He has received his Bachelor of Science degree from Western University and is interested in pursuing a genetic counseling career. Mitch is also a retinoblastoma survivor and an active participant in the Canadian Retinoblastoma Research Advisory Board, as well as attends monthly working group meetings and participates in CRAB projects, such as the creation of the Retinoblastoma Research and New booklet. And Dr. Jennifer Steeves is the York Research Chair in Non-Invasive Visual Brain Stimulation, as well as the Associate Vice President of Research at York University, and studies brain plasticity and is especially interested in monocular and binocular vision. I had learned monocular vision is with vision through one eye, and binocular vision is with two. So that was something that I learned. Dr. Steeves is a longtime member of the Canadian Retinoblastoma Research Advisory Board and attends monthly working group calls, as well as our annual Retinoblastoma Research Symposium. So I want to thank you guys for coming today and sharing this research and speaking to us in a casual conversation. So Mitch, I'm going to pass it over to you. I'll stop sharing. And when you need me to launch the polls, just please let me know.
Okay, thanks for the introduction. I will switch over here. And I always do that thing. I feel like, okay, can we see? Do we see the slides?
Yep, perfect.
Okay, very good. Yeah, so thanks for the introduction, Ivana. I'm Mitch. I am, as you said, a retinoblastoma survivor. I'm doing this plain language summary. And today we're doing the paper by Krista Kelly, Dr. Galley, and Dr. Steeves. Early monocular enucleation selectively disrupts neurodevelopment of face perception in the occipital face area. And that's a mouthful, a lot of big words in there that are definitely hard to understand if you're not well versed in this stuff. So we're going to run through this, hopefully understand a little bit more about it by the time I'm done. And yeah, as you know, put your hand up, leave some comments in the chat if you have anything you want to talk about as we're going through here. I think this would be probably better done as more of a discussion than like a lecture style, but if it ends up being more of a lecture style, I'm happy with that as well. So to get started here, I want to share kind of my journey with retinoblastoma. Obviously, retinoblastoma being a childhood disease, it is something that you kind of live your whole life with. You have a diagnosis very early, and then you are kind of, you know, you're living with that for a long time. So here we have a very rudimentary depiction of a family. This is my family. This is my dad. This is my brother, Mac, is the little boy you see there. That's my mom, and I'm the baby. And at this time, probably, you know, mom and dad were elementary school teachers. They were starting a family. My brother's 2 years older than I was. Had a pretty, mom and they might disagree. They're on the call today, actually. I won't have them tell you about this. They had relatively uncomplicated pregnancy with Mac. He was healthy, you know, had no problems. We had no history of, you know, childhood diseases, certainly no history of childhood cancer. So really, we had no reason to believe anything would go wrong until it was summer of 2001. I was apparently a drama queen playing pirate or, you know, dress up or pirates or something with my mother. And I must have been struggling to get the eye patch on because I remember she did it for me and she happened to put it on my left eye. And it was, I told her in that moment, I said, you know, Mom, I can't see. I put it on the other eye. And so, if you have a small child, you might be able to imagine a 3-year-old might try to play a trick on you, think that's kind of funny to say, haha, mom, I can't see you. So she was, tested it out. She said, Mitch, sure you can. Like, how many fingers am I holding? I held up 3 fingers. And I said, no, mom, I don't know. I can't see you. And so that was alarming to a mother, to say the least. And so we were very fortunate that my aunt, her sister-in-law, was working at an eye clinic at the time in my hometown, Owen Sound. She was working with an ophthalmologist, and we were doubly lucky that this ophthalmologist, Dr. Hiscox, had actually seen retinoblastoma before. So I was in the clinic that afternoon, was examined that afternoon, and was pretty well confirmed that's what I had, and was on my way to Sick Kids in a matter of days. At Sick Kids, this is the part that I hardly remember. It was a lot going on. I was very young, but what I do know is that I was, again, as lucky as you can be to have a rare disease like this. I was about that lucky, because the tumor had managed to, had not metastasized, is the scientific term, had not kind of spread elsewhere in my body, despite the rather large size of it. And they were able to enucleate for cure. So as you can maybe tell, I underwent early monocular enucleation, as the title of the paper says, did not undergo any kind of chemotherapy, radiotherapy, and have honestly lived a pretty normal life after that. Had a normal childhood, normal teen years, pretty normal young adult years, played music. My family's very musical. That's the Atlanta Falcons, but that was also my high school logo. Got into theater, got into the arts, did swimming, kung fu, strength training, stuff like this. Never really got into contact sports, but that was less because I couldn't and more because I didn't really have an interest. But I think that mom is happy about that regardless. Even though I did have a pretty normal kind of younger years, I always kind of knew that being introduced to genetics so early, and especially genetic disease so early, I was really fascinated by the impacts that genes can have on really on your whole life. So I knew coming out of grade 12, going into university, that genetics was something that I wanted to study. My classmates really agonized, oh, what am I going to do? Is it going to be engineering? Is it going to be math? Is it going to be psychology? For me, it was genetics, and there was really no other choice. And as Ivana said, I'm now thinking about the next step, looking at genetic counseling programs. There are 4 in Canada. I've taken 1 off the list because they've rejected me already. They're very competitive, but yeah, have applied for that, and we're underway. So now that that's out of the way, we'll get to the actual potatoes of this, which is the article. And so again, we're looking, what kind of drew me to this article were 2 things. Firstly, words early monocular enucleation describes me. That's something that, I underwent, and that has been my life for the last 21 years. The interesting thing is the second part of this title, I felt does not describe me. Selectively disrupts neural development of face perception. So I saw this title and I kind of saw it like this, didn't see all the words. I saw early monocular enucleation disrupts face perception. And I thought, that's weird, because that's half of that's me and half of that's not. So I was really interested to get into this and to see how they were going to kind of reconcile those ideas in the paper, or see if, I would feel that they were adequately reconciled with my lived experience. So I had kind of 2 big questions coming into this. First question, the article is talking about face perception specifically. So I was wondering, is there a reason we might be interested in face perception over other types of perception? You like, rather than objects, rather than places, rather than like bodies generally, we're only interested in faces. I thought that was interesting. The second question is, that what I'm saying, are they saying that I'm worse at distinguishing faces than people with 2 eyes? Because again, I didn't feel that described me. To focus in on the first question here, we have a poll question coming up. And the fact that I'm asking this is probably tips you off that there's something weird going on here. But when you look at this picture, how many faces, how many different faces, unique faces do you see in this picture? So I know it's a weird kind of leading question. There's something fishy going on here, but try not to think too hard about it. I'll give you maybe like 45 seconds, a minute or so, or whenever Ivana has the stats. I don't know how many respondees we have. When we have a sufficient number, we can take this up here. Actually, I can't see the chat, I don't think. So if there is anything showing up, sorry.
Does anyone need some extra time? I have 16 people answered questions, 17.
Will we
Okay,
get
we
those?
have 18.
Okay, 18.
So maybe we can go ahead with, I'll
Yeah,
share
a
the
look.
results so everybody
See
can
what-
see.
Where's
So
that?
we have 4 out of the 18 said 1, 5 out of the 18 said 2, 3 out of the 18 said 3, 3 also said 4, and 3 also said 5.
Okay, that's good. That's what I was hoping
Oh.
for. There we go. 4 out of the 18, I'm wondering, I know there are 3 authors plus me, we might be advantaged, but so this may surprise you. This is actually one face. What they've done is they've changed the proportions, the distances between the features. If you actually look at the features though, look at the lips, the kind of glisten on the lips there, the size of the nostrils. If you pay really close attention, you can see this is actually one image that's been doctored to, create the illusion that they are different faces. And I'm so glad that we did have all kinds of different answers, because it's proving my point, which is good. I was worried we might not. That can change your perception of the entire face, the distance between those features. So that's weird, that our brains behave like that. I have another, there we are, another poll question coming up. This one is even more leading, maybe. Which one of these faces is not a real face? One of these was kind of created in Photoshop. And I'm wondering if you can tell which one that is. Top left, top right, bottom left, or bottom right. Can we run that poll, Ivana? And again, we just kind of, I don't know how many we are. Are we 18?
We have 24 here and
24.
19 answered. So, 20.
There we
It's a
go.
lot faster this time around.
Yeah, again, these are trick questions. So it's not, we're not grading you. That is for sure.
Okay, we have 22 answered, so I'm going to share the results.
Okay. Top left. Okay, so I'll be honest. It was the way I worded that question was kind of bad, because I actually don't know for sure which one it is. But the point is, you can see that the 4 faces look like, complete faces. But now on the right side here, if we kind of split them up, you can see on the top, the misaligned faces, those are actually the same set of eyes on those 2 top misaligned images. Does everybody see that? It's actually the same set of eyes and eyebrows. The nose, the bottom half of the face is different. So actually, I don't know which one's the real one. But one of those, they've mixed and matched the eyes and the kind of jaw portion of the face, which is yet, both are believable as being natural faces. So again, something strange is happening in terms of the way that our brains put together faces, you know, the way that the features fit together, the way that the spacing fits together, makes for a really interesting picture. This is probably a bad example, but I thought this was kind of funny. You know, what if we were going to look at like places? It's hard to say whether we're looking at places or objects here. You have two freestanding towers, relatively iconic, obviously CN Tower, and I believe, apologies for my pronunciation, Burj Khalifa in Dubai. And if we put them together like those faces, it's pretty obvious that, you know, our brains aren't going to trick us there. We know that that's two different images, where with the faces, you know, we could kind of mix those features and come up with an interesting product. So, you know, there are a number of theories for why face perception is maybe different from other types of perception. For the purposes of what we're doing here, not really important like to us why it is. It's just kind of important that we understand that face perception is a special kind, and that it is special and works differently in our brains. Another thing to point out here is that face perception is what we call localized in the brain. That means that there's actually a particular place in the brain that you can kind of point at and say that, you know, this is where face perception happens in the brain. You can tell that by looking at brain activity while you look at images. So we've got here, just for completeness, the green is where places are processed. This is an image of, I believe, Tokyo, something like that. Point is, it's a place you could visit on Earth, you know, and your brain has a spot in it to process that and like have, you know, send that signal to you that that is a place. The blue here is what's going to do faces, and that's the place in the brain where, again, you know, those signals come together and you know, the message is sent that this is a face. I'm looking at a human's face. Red, the red spot is where objects happen. The signals are put together. Your brain comes up with the idea that I'm looking at an object, something that I could interact with in the world. So back to my questions. The article is talking about face perception. Is face perception special? Answer is yes. Face perception is really special, and it does have different mechanisms in the brain that are going to make it behave differently from other types of perception. That's why we're going to be looking into this in this study. So now time to get into the actual study itself and look at my second question. Are they saying that people like me who underwent early monocular enucleation are worse at distinguishing faces than people with two eyes? And so let's look at that. This study that we're talking about today is actually a follow-up to a previous study. That study, I'm kind of giving away the answer here, found a small but consistent decrease in the processing speed of faces in people who with early enucleation compared to people with bilateral vision. I may take a moment. Jen, do you want to expand, or Krista, do you want to expand upon kind of the magnitude of that difference, or talk about what happened in that study just briefly to kind of orient us to why we would be doing this study?
Yeah, I don't, Krista, you might remember better than me. It's very small. So it's not like you would notice that anybody had poorer face processing ability, but there was it was a little bit slower. So it was something that was very subtle. And because we know that, as you explained, there's a special network within the brain that's dedicated to faces that's different from objects and other images in the world, we wanted to see what was going on in the brain in terms of activity. So that was Krista's work.
Yeah, and it was my very, very first paper that I ever published, and I can't for the life of me remember exactly what the results were. But I think the gist of it is that it took participants longer to respond, but that they were still accurate from what I remember. So the processing speed is a little slower, and that might be because of the lack of binocular information, so lack of information from two eyes.
And when we say a little slower, like, are we, like, how much slower do you remember?
Oh,
roughly?
it'll be like milliseconds.
Like milliseconds.
Yeah. And so the thought is that, you know, if someone's taking longer to do something, do they have different wiring that it actually is taking longer to route through the system?
Mhm. So, and thanks for giving us some insight to that, because that definitely does orient us exactly to my second point here. This study is asking what's happening in the brain. Are we seeing different wiring patterns? Are we seeing, what is happening in the brain to make it the case that we have these small differences? So this study, we're going to use functional MRI to look at blood oxygenation. That's a fancy science word to say how much oxygen is in the blood, which is a good measure of brain activity without sticking electrodes in your brain and causing all kinds of ethical problems. So here's kind of a little demonstration, or not demonstration, little image. On the left, we have a person who has undergone monocular enucleation. They have their different eyes there. Maybe that's their prosthesis on the right side. On the right, we have someone who has binocular vision to normalize. We're going to put them in an MRI machine. This is medical imaging. And we're going to actually look at their brains, again, look at the blood in their brains while we show them different images. First, we're going to show them images of things. So apples, trucks, basketball, stuff like that. We're going to show them, the numbers aren't super important, but just so you know, it was 16, I believe, 16 objects. You see each image for 1 second each, with 1 second break between each object. Then you'd get a brief break of, I believe, 16 seconds. Is that true? Anyways, something like that. And then you would be shown 16 faces. Now, I know I just told you these are actually the same face, but you would be shown 16 different faces with the same protocol. 1 second to view each face, 1 second between each face. You'd get another break before you were shown 16 places. Same thing again, shown each place for 1 second with a 1 second break between each one. While we were doing that, remember, we'd be looking at the face area in blue with our MRI scanner. We would be actually looking for oxygenation in that area of the brain and comparing that between monocular and binocular people. And so don't get scared. This is a scary image that I was afraid of when I first looked at it, because it's dark and I don't know what's going on, but we're going to walk through it and we're going to figure it out. So first things first, we're looking at the brain. Imagine if you took a cross section of my head about here, kind of here maybe, and we're looking down into my head like this. That's the angle that we're looking at here. On the left says control. That's the person with 2 eyes. On the right says enucleated. Obviously, that's the person with 1 eye. And so these are actually at slightly different elevations through the head as well. The control, I believe, is higher up. The enucleated looks like it's right on the eye level. I thought this was kind of cool. It looks like this person has a prosthetic right eye, and that looks like the prosthesis and the implant in there from what I know of MRI images, but I'm not an MRI expert, so that may not be the case. So yeah, we're looking at these brains here, and what we're focusing in on, remember, the face area. It's not, it's not perfect. Obviously, this is a perfect rendering of a brain. Real brains are different, so that face area is showing up slightly different position, but you can see the red areas drawn onto the brain. These are areas, visualizations of that blood oxygenation, that brain activity. And these graphs down here, the bold signal is blood oxygen level detection or something to that effect. Basically, again, it's the measure that we're using, that blood oxygenation brain activity measure. So, but the long and short of it is, there is, sure enough, less brain activity in that face region of the enucleated brain compared to the control brain. So that's interesting. We see less activity. That matches the results of the previous study. We saw slower detection. But what can we really draw from that? This is something that you kind of have to get used to with scientific articles. You can draw exactly what they say. There is less activity in the face area. That's different from saying that you have an impaired ability to distinguish faces, or different from saying you have an impaired ability to perceive faces. you probably are a little bit slower on the order of milliseconds, like Jen was saying, but we do have to be careful at the conclusions that we draw from that. So revisiting my questions again, question 2, are they saying that I'm worse at distinguishing faces than people with 2 eyes? Maybe a little bit. It sounds like probably a little bit, but not enough that I'm noticing in my day-to-day life. You know, I can tell Jen and Ivana and Brenda, I can tell pretty immediately that, you know, you're all women wearing glasses, but I have no problem telling who's who, you know, at a glance. It's not something that I'm noticing in my everyday life. So something that we're obviously thinking in this in our group here is, what is the impact for a survivor of this research? And in the case of this study, it's not a big impact for the survivor. We, you know, like I keep saying, I don't notice this. It doesn't really matter where the blood goes in my brain as long as I'm able to distinguish those faces. Now, that's not to say this is a bad study or this is a low impact study that we don't care about. I'm going to get into that more in a minute. But the big idea is that the brain is what we call plastic. Now, plastic doesn't mean like a Fisher-Price toy. It means that it's able to change what it does. It's able to rearrange its connections. As Jen was saying, the, you know, recircuiting the brain is maybe what's going on here, depending on what's available to it. Obviously, having 1 eye compared to 2 eyes is a big change. You only have that one visual input. And visual input is a big deal to humans. We have really evolved around having a very strong visual input. And having half of that taken away is going to have some big impacts on the way that your brain works. Not for better or for worse, but just to say that it's going to change. So something we always talk about, scientists are always thinking about when it comes to experiments are, what are the limitations of the experiment? The big one here, we had a small, oh, sorry, I just saw the chat. I didn't see the, I didn't see the chat. Did it make a difference which side of the brain studied? I don't believe so. See, now this is interesting, actually. Maybe Jen might be better able to, or Krista might be better able to comment on that, because I know that it is, you know, this, I don't know if we have a contralateral thing going on, me having my left eye, would that be right brain? Or it's a very good question that I don't think was really a focus of the paper, but do you want to?
Yeah, so face processing is often bilateral, but tends to be more right hemisphere dominant. So it's kind of like, you know, language is often coded in the left side of our brain and faces in the right side of our brain. So there was no effect of, you know, eye of enucleation or, you know, left or right hemisphere.
Okay. Oh, and I see you actually answered that in the chat. Holy smokes. Maybe my text processing needs work. Holy smokes. Okay. Anyways, I was talking about limitations. Yeah, something scientists are always thinking about, limitations of a study. No study's perfect. And just because a study has limitations doesn't mean it's a bad study. In this case, big limitation was the sample size. We had 6 people who were enucleated during, you know, had early monocular enucleation, and we had 10 people, I believe, with binocular vision. We would want to make, if we want to make generalizations at a population level, if we want to say that this is always true, we should really have a bigger sample size. Because the way that I like to explain this is, if you can imagine you have a room of 1,000 people, and if you're taking a sample of 10 people, you're running a study what's the average population proficiency at basketball, and you have a study or a room of 1,000 people, and in that room you have the entirety of the NBA player base. And so if you take 10 people, you might get LeBron James, Kyle Lowry, you know, Kawhi Leonard. In that sample of 10, it might happen that you just get 10 really good players. And then obviously those people are not representative of the average population basketball skill. Where if you take a sample of 500 from those 1,000, there aren't 500 NBA players. There aren't enough people that are that good that could, you know, skew your results to that level. So you're protected against what we call sampling bias. When you have a larger sample size, that's something that we always want to achieve in a study. Of course, to give credit to the authors, people who undergo early monocular enucleation are very rare people. Retinoblastoma is, in the ballpark 1 in 10,000 to 1 in 20,000. I don't know where the stats are nowadays, but something like that. And there are relatively few other reasons why you would, whether it was a traumatic injury or a cancer or some other disease, there are relatively few reasons why you would undergo monocular enucleation at a young age if there were any other options medically. So hard population to recruit, and 6 might be kind of impressive. So really, that's kind of the big limitation that I was really keenly aware of, because again, I'm not an expert on the methodology. But another thing, so to talk about next steps, obviously what we talk about in this group, we want to get our results, want to get our research kind of improving the lives of survivors, making better outcomes for survivors. So just because this isn't a study that's kind of directly looking at outcomes doesn't mean that it's not contributing to that story of outcomes, and doesn't mean that it's not valuable. Next, we might, want to look at more aspects of like other senses, monocular vision. We've been looking at kind of comparing vision between monocular and binocular people. We might want to look at other senses, compare those things between monocular, binocular. We might want to get back in the MRI, look more closely at that brain activity, see if we can learn something else. Has that brain activity that's been lost in face perception, has that gone somewhere else in the brain, or has that been kind of refunctionalized to something else? We might want to look at these things together, get a better picture of that. Do we have, better hearing maybe in these people, more of the brain dedicated to other senses in people with early monocular enucleation? And eventually, maybe we do get to the clinic, maybe we don't. But at the end of the day, having a better understanding of the brain, how it's organized, how it works, is, always a good thing for science. And I think that a good thing for science will always be a good thing for survivors, is kind of my soapbox moment there. So honestly, that is about all we've got. I see I might have taken a little longer than I expected. I'll now open the floor to questions. Yeah.
There was a question. I wonder if there's a difference in perception with age, because it took me longer to answer the poll. I wonder if age or any other factors could have made a difference.
It likely could as well. And that's another thing to maybe talk about, other factors that could be impacting that speed, impacting that brain activation. Of course, I think it was a good study. I think that monocular enucleation definitely does have an impact. But yeah, fun question.
Another question I think was answered in the chat was what is considered to be early for the purposes of the study, and then the answer was given 5 years or younger. Yeah,
I believe it was 5 years or younger.
And the next question, what about monocular developmental abnormalities? Would their answer be the same? Dr. Payton, if you would like to maybe elaborate on the question. I see there's some wondering if maybe, is it like strabismus or cataract?
So I wouldn't think strabismus, and cataract, maybe not a great choice either. I wanted something that was almost like enucleation, but wasn't. If you had a developmental microphthalmus, anophthalmus, something where the vision would never be even 2200, 2400, but to see what happened with the vision processing, or is face processing still showing the same thing as an enucleated eye?
I'll just maybe comment and say that I don't know about face processing with microphthalmia or any of those disorders that you suggest, but I suspect that it might not be as good an outcome as with eye enucleation. I think the interesting thing with eye enucleation, and when you look at the brain, is that you don't have abnormal signals coming from each eye. And you have one pure clean signal, because the other eye is diaphanted and there's no anomalous input to the developing brain. So I think the outcomes with eye enucleation are actually, on the most part, very positive. So this turns out to be a paper that I would not have chosen to talk about, because it is really one of the only ones. Krista has done so much of this work together in our lab, and most of it is a different kind of outcome, and face processing is a really unique and vulnerable system to abnormal visual experience early in life.
So Jennifer, just to be clear, I was thinking about the monocular ones, not where they've got a binocular developmental anomaly, where they've got a monocular one. It should give you the same result as this, I would think.
Potentially it could. So what I was thinking of is cases where they do have some input from that eye, even if, as you say, it's not a good signal. But yeah, I don't know. I don't think it's been done. I don't know if Krista knows.
You know, I think the reason why we did the study where we looked at the behavioral one, where we just saw that they were responding slower, was because there was some research showing that adults that had a congenital or developmental cataract early in life, that they were slower also, that they had some issues with face perception. And that's why we kind of, you know, did it with the enucleated participants, because it's, you know, a different kind of anomalous binocular input. And I will say that I know that cataract outcomes can be very poor, especially in people who are adults right now. I know that there's surgeries are getting better and sooner, so you're getting better outcomes with kids these days. But for adults, they would have had pretty poor vision, so probably 2200, 2800. So that's the only other thing that I can think of that would be kind of similar to microphthalmia.
Does this also answer your question, Michelle, about instead of a enucleated eye, an eye that has low vision? She says yes. Okay. That is all the time we have. Unfortunately, I think we started having a really great conversation here today. But I want to thank everyone for participating and for coming to join us at this cup of tea event. I wanted to mention, if anybody's interested in partnering with somebody to write a plain language summary and participating in one of our future cup of teas, please let me know. I think, or I would love to have some more volunteers. I'm looking for volunteers who have personal experience with retinoblastoma, and then I can work with you to partner you, find a partner in an article and guide you through the whole process. But Mitch, this is a fantastic presentation. I really enjoyed it. I learned, but it was also very easy to understand the way that you presented. So thank you so much. Thank you, Jennifer and Krista, for attending as well, and everybody else for joining us here today.
It's Brenda. Could I just add, Mitch, you've done an incredible job presenting this. It's absolutely beautiful. Thank you very, very much.
Thank you. Thanks for coming. Yeah, I'm glad you enjoyed. I'm glad you think it was good.
Excellent. It was really, really good.
I agree. Very well done.
Actually, can I just say something to the group? Just because, Mitch, you raised a really good question, you know, what's happening with other sensory systems? And so we've actually done a lot of that work in our lab. And I'm giving a talk in a couple of weeks at the university, and it'll be on Zoom. It's on a Friday afternoon, and I can share the link to it so that it could maybe get posted. So if you happen to be free on a Friday afternoon, you would be more than welcome to come and hear it. And I'm talking specifically about the hearing adaptations.
That's wonderful. Thank you.
That's great. We can share that info too on our social media as well. Okay, I know there's a tumor board meeting next, so thank you guys so much for being here and have a great evening.
Bye.